In this problem, we're going to practice taking the derivative of this function x over the square root of 2x squared plus 3. And as you should immediately be able to tell, it will involve using both a quotient rule and a chain rule. In problems like this where it can get confusing, where you're doing two different things at once, I like to make sure that I break it apart. So remember, let's just call this h of x. So then we can call the top f and the bottom g. Remember that the quotient rule says that low d high minus high d low over low squared. So that's going to be our derivative there. So we'll need to know both f prime and g prime. So I'm just going to take those off to the side so that we don't get confused. So if f is the numerator, which is x, then this one's easy. Then the derivative is 1. For g prime, however, things get a little bit trickier. To make things easier to take the derivative of, I'm going to rewrite the square root of 2x squared plus 3 as instead 2x squared plus 3 to the 1/2. So the chain rule here, which we'll have to use because we have an inside function that's not just x, says we'll have to take the derivative of the outside first. So 1/2 times leaving the inside the same. So the negative 1/2. That was just the power rule. So I took the 1/2 out in front and then subtracted 1 from the power. But then the chain rule says that we have to then multiply by the derivative of the inside, where the inside is the 2x squared plus 3. So the derivative of that would be 4x. Okay, we'll just simplify that a little bit so that when we throw it into our quotient rule, things will just be a little easier for us. So 1/2 times 4x, that's going to be 2x. And then 2x squared plus 3 to the negative 1/2. We can rewrite that in the denominator by changing that exponent to a positive. And of course, we know that's the same thing as 2x over the square root of 2x squared plus 3. Okay, so that's the simplified form of our derivative there. So now, plugging everything into our quotient rule, we get g, square root of 2x squared plus 3, times f prime is 1, minus f, which is x, times g prime, which is the 2x, divided by the square root of 2x squared plus 3. And then divided by the bottom squared. The square root and the square cancel out nicely, and we're left with 2x squared plus 3 here. So we could leave this like this. A lot of times we'll be asked to give the most simplified answer though, and in this case we have a fraction within a fraction, and we don't normally like that, so let's try to get rid of that. Easiest way to get rid of this is going to be, well, let's just multiply by the square root of 2x squared plus 3, so that cancels out. But if we're doing that in the numerator, we of course have to do that in the denominator as well. Okay, so I'm just going to distribute this to each term. Here, square root of 2x squared plus 3 times the square root of 2x squared plus 3. The square roots cancel each other out. And then, here x times 2x minus 2x squared, and then the square root of 2x squared plus 3 in the denominator, and the 1 in the numerator will cancel each other out. And then in the bottom, we have 2x squared plus 3, which is like 2x squared plus 3 to the first. And then the square root of 2x squared plus 3, which is like 2x squared plus 3 to the 1/2. We have the same base, so we can just add the exponents, and we get 2x squared plus 3 to the 3/2 now. Okay, so our final answer with the 2x squareds canceling each other out would be 3 over 2x squared plus 3 to the 3 halves. Hope that helps, and let me know if you guys have any questions.